at all locations. The data which is there, that is present at all locations, but it is same, not a same content. So schema refinement mainly used to reduce the minimum redundancy, and also some reduce the anomalies. Like, to maintain the good relationship database design, we are using the schema refinement. So let us start. So why we need to combine schemas, all those things I'll explain. Before going to this one, I need to explain relational database design. So relational database design, in that again, features of good relational database design, this is fourth phase. Like, we are having six phases. First one is requirement analysis. After gathering the requirements, physical schema, logical schema, and this is the fourth space that we need to maintain the good relational design. So mainly good relational design is to, why we need to go for good relational database design means to generate the set of relations having minimum redundancy and to reduce the anomalies. Okay, so let us see what is the anomaly, what is minimum redundancy, all those things. First, see this slide. What is combined schema? We already know. 1 minute, ma. So combined schemas, if you observe here, this is a table which consists of ID, name, salary, department name, building, budget. So suppose we are combining this instructor table and department table, like instructor department table, we can get all the columns in a one table. If I'm separating these two tables, like instructor table different and department table different, like we'll be getting the one table like ID, name, salary. Okay, ID, name, salary into one, and next ID, department name, building, budget. This is related to department. Okay, so instructor table is consists of column names like ID, name, salary, and department consists of ID, department name, building, budget. Why I'm repeating again ID column means, if we join, like lossless join will be there. If we join this table, again we have to get this same table. If we are combining the two tables of instructor department table, we need to get the same table. Okay, are you getting my point? Yes or no? Okay, so first instructor table consists of columns ID, name, salary. Okay, again coming to the second department table. Okay, department table consists of ID along with department name, budget, building. Why? Because building and budget are related to department. So if we combine also these two tables, we'll get the single table without any repetitions. Sometimes may it possible to get the repeated of information. Okay, like department names may get same and salaries may get same. Okay, but IDs will be different. That's why in each and every table, like we are splitting into two tables right here. So if in instructor table, ID column is there. ID will be having unique values, and as well as in department, ID will be there. ID column will be common column to the both the tables, so that we can get the information very easily by using the ID column. So this is the key one. We can also call as a identification key. Okay. So as combined schema without repetitions, what will happen? Sometimes will be get confused. Like consider combining the relations like a section class consists of section ID, building, room number, and section consists of course ID, section ID, semester, year. So these we are making into one relation. How section class and section will be combined as a section relation, which course ID, section ID, semester, year, comma, building, room number. Okay. So here if you observe in section class, which is the common one, section ID. In section, same. So we are making into one column. Okay. So consider combining relations. Two are there here. Section class, section, which consists of columns or attributes, section ID, building, room number. And section is one more relation. Column consists of course ID, section ID, semester, year. So if we are combining this relation into one relation, these two relations into one relation, will get section as a relation, course ID, section ID, semester, year, building, room number into a one relation. Here no repetitions will be there. Here only a single column, section ID we got by combining into one relation. Is it clear? Yes or no? Ma, please be interactive so that I'll understand whether we are listening or not. Next, what about smaller schemas? Before going to this decomposition, let me explain what is minimum redundancy. Okay. Minimum redundancy is nothing but already we know the term or word redundancy. Redundancy is nothing but storing the same data at different locations. That means data is repeated in multiple tuples and same relations or same will be in different tables. Same data will be presented different tables. With redundancy, we'll be having the one disadvantage. Most important disadvantage is it is a wastage of space and time. Why? Because the data is repeated in all the tables, in multiple tables, right? Redundancy is nothing but copy of data. Redundancy means storage of same data at different locations. That means data is repeated in multiple tuples. So by this, we'll have the disadvantage like wastage of space and time. So for that, we need schema refinement. To reduce the redundancy, we need schema refinement. Okay. Why we need schema refinement? To reduce the redundancy. So redundancy in schema is most important problem. Okay. Redundancy is the most important problem in a database. So coming to the this one, anomalies. Anomaly is nothing but a problem or a issues uh, or a difficulties while we are doing any creation of tables, any inserting table, we'll find some difficulties. So like that, we are having uh, insertion anomaly, update anomaly, delete anomalies. Along with the minimum redundancy, to maintain minimum redundancy, we go for schema refinement, and to delete or to avoid insertion anomaly and delete anomalies, update anomalies, we go for schema refinement. Okay. So what is mean by insertion anomaly means? Insertion anomaly is nothing but if there is any existence of dependency attribute. Existence of dependency attribute is nothing but here, if you take one example, wait 1 minute. Let me open Notepad. Hmm. So insertion anomaly is nothing but insertion. What will happen if there is any existence of dependency attribute? If suppose two columns are there, two columns, names, like in a employee table consists of columns like ID, comma, name, comma, rating, comma, salary. Okay, these four columns are there in an employee table or employee database. Suppose this employee table consists of rating and salary in employee table. Based on rating, salary is going to fixed. Okay, based on rating, salary is going to fixed. Like based on your marks, percentage going to fixed, or percentages will be given, or percentages will be calculated, right? So based on rating, salary is fixed in an employee table. Suppose a 8 rating employee will be having 50,000 salary. Coming to 9 rating employee, 1 lakh salary. Next, coming to 10 rating employees having some 2 lakh salary. Okay. So what I'm trying to say here is salary is dependent on his performance. Salary is dependent on his rating. Your percentage is dependent on your marks. Okay. What will happen here in insertion anomaly if there is any existence of dependency attribute? What is dependency attribute here? Salary. Salary is dependent on rating, right? So based on rating, salary is fixed. Like 8 rating of the employees will be having 50,000 salary. 9, like 1 lakh. 10 rating people are having 2 lakh salary. This was fixed by a company or a organization. So where rating appears need to be increased. So like salary should also increase. So without inserting, what is mean by insertion anomaly means without inserting the value of rating, this salary column will not exist. Okay, without inserting the rating, salary will not exist. Suppose an employee is having 7 or 8 rating, his salary should be 50,000. Without entering these rating numbers, it is not possible to insert the value into the other column. That is called as insertion anomaly. Yes, are you getting my point? Yes or no? ఏమ్మా ఉన్నారా? Okay, let me explain once again what is mean by insertion anomaly. If there is any existence of dependency attribute, okay, if there is any existence here, what is the existence of dependency attribute? Salary is based on rating. Marks, your percentage is based on, if మీకు మార్క్స్ వస్తేనే కదమ్మా పర్సంటేజ్ క్యాలిక్యులేట్ చేయడానికి. So here the main column it should contain in a table is rating to give a salary or to fix a salary by the organization. Okay, so similarly here what is mean by insertion anomaly means without inserting a value, నేను ఇక్కడ రేటింగ్ వాల్యూ ఇవ్వలేదు, రేటింగ్ వాల్యూ ఇన్సర్ట్ చేయలేదు, సో శాలరీ కాలం అనేది ఎగ్జిస్ట్ అవ్వదు. దిస్ ఈస్ కాల్డ్ యాజ్ ఇన్వాలిడ్ టేబుల్, రైట్? సో ఇన్సర్షన్ అనామలీ అంటే అదే. వితౌట్ ఇన్సర్టింగ్ ద వాల్యూ ఇట్ ఈస్ నాట్ పాసిబుల్ టు ఇన్సర్ట్ ది వాల్యూ ఆఫ్ అదర్ కాలం. ఇప్పుడు రేటింగ్ ఇన్సర్ట్ చేస్తేనే శాలరీ వాల్యూ ఇన్సర్ట్ చేయడానికి వస్తుంది, లేదు అంటే ఇక్కడ మనకి ఎర్రర్ చూపిస్తుంది. ఎస్ ఆర్ నో? సో వితౌట్ ఇన్సర్టింగ్ ద వాల్యూ ఇట్ ఈస్ నాట్ పాసిబుల్ టు insert the value of other column, called as insertion anomaly. Next, update anomaly. So here in insertion anomaly we can also said to be a functional dependent. Why? Because salary is dependent on rating, so we can call it as functional dependency. Okay, so functionally where rating is functionally determines the salary attribute. Salary is dependent on rating. Okay, we can call it as insertion anomaly as a functional dependency. Next, update. So update anomaly. Anomalies is nothing but facing the difficulties, issues or errors. Simply remember errors, insertion errors. While inserting the data, we'll getting some errors. While updating the data, we are getting some errors. While deleting the data, we are getting some errors. So that are called as anomalies. Okay. So coming to the update anomalies, as we already know the association between rating and salary. Yes or no? So here salary is dependent on rating. So at any point of time, user can able to change or update the correlation between the rating and salary. So this may leads to inconsistent state. Okay. So for example, see here, 100 records are there. 100 records are there in a some employee table. Okay. So 100 records are related to this 7 rating or 8 rating. 100 records are related to 8 rating. Okay. Now what I want to do? Now I want to update the statement or update the table 90 records salaries from out of 100, 90 record salaries from 50 to 75, 50 to 75,000. Okay, 50 to 75,000. So with the impact of the rest of 10, what about 10 then? Even that 10 also, 10 records are also having the 8 rating, right? So what happens here? Here the data will be in inconsistent state. Why? Here it is 8 rating. Okay. Next, again 10 records which are there, 10 records which are there, that is also 8 rating, 8 rating. But here the data is same. These people are having same 8 rating and these people also having same 8 rating. But I have updated to only 90 records. So this may leads to data inconsistent. The data is present at different locations, multiple data, but the data is not same in two locations, two places. Okay, is it clear? Yes or no? Ma, please be interactive, ma. This is very important concept. So till now I have explained insertion anomaly. Next, update anomalies. Update anomaly is nothing but, as we know, rating, salary is dependent on rating. So it should be the data when we are going to update the data in many places which is there, that should be data in consistent state, not in inconsistent state. Okay. Suppose I want to update the 90 records from the 100 records which are having 8 rating, 50 to 75. Okay, what about then remaining? Remaining people also having 8 rating, right? So the data will be leads to inconsistent state. So this is what update anomalies. Next, delete. Delete anomalies. If you observe here, what are DML commands? Select, update, insert, delete, right? So we are performing some anomalies, not we will be getting some anomalies during performing the DML operations. Okay. So delete. Delete anomaly is nothing but if I give a command in order to delete 8 where in order to delete where rating is 8, rating is 8. My intention here is to delete only the column of 8 rating, but here what will happen? While I'm giving the command delete uh, delete table or column like table name. So where we need to give condition where rating equal to 8. Suppose I'm giving rating equal to 8. So what will happen now if I'm giving this command means it is going to delete rate column as well as salary. Why? Because salary is dependent on rating, and who people are having 8 rating employees, all the data will be deleted. So this is a big disadvantage, right? It will delete 8 rating, but in turn, it will delete the rating 8 along with the content of salary value who are having 8 rating. Okay. So what is the delete anomaly? If I am giving a command delete, in order to delete rating is 8, it is going to delete the column of 8 rating. Who is having 8 rating? That people columns or attributes tuples will be deleted, as well as the salary amount also deleted of the those 8 rating people. So this is a delete anomaly. Okay. So to avoid all those things, insertion anomaly, delete anomaly, update anomaly, redundancy, we go for schema refinement. And also we go for normalization topic, normalization concept to delete, to avoid all those things. Okay. Next, there are some properties. Up to this clear? Yes or no? Guys, are you there? మా ఏమైంది, ఉన్నారా లేదా? Next, let us see what is meant by decomposition. Okay. So decomposition is nothing but breaking down into parts or elements. Decomposition is nothing but breaking down into parts or elements. So it replaces a relation with a collection of smaller relations. So similarly, we have seen this is called as a this one section, class and section. We are making it to one relation, right? So we can call this also decomposition, or you can take this one. So we are making into two tables by using this instructor and department. So we are making or into two multiple tables, right? Instructor table and department table. Okay. Decomposition is nothing but process of breaking into parts or elements, so that it replaces a relation with a collection of smaller relations. It breaks the table into multiple tables in a database. Now, coming to the properties, we know that what is meant by decomposition. Decomposition is nothing but breaking down, or simply remember a table is there, we are making into multiple tables. Okay. So some properties are there under decomposition, that is lossless decomposition, dependency preservation, lack of data, redundancy. So these three are very important when we moving for normalization. First one is lossless decomposition, dependency preservation, lack of data, redundancy. First one, lossless decomposition. So what is meant by lossless decomposition? Main ultimate, the name is, while we are decomposing, while we are combining the schema, it should be lossless. Okay. So decomposition must be lossless. It means the information should not get lost. When we are combining, when we are splitting, the information should not lost, okay, from the relation. That is what lossless decomposition. When we are joining also, the information should not lost from the database. Okay, so it gives a guarantee that join will result in the same relation as it was decomposed. This is an employee department table. Okay, one table, employee table and department table, combined table. So employee department table consists of columns like EID, name, age, city, salary, department ID, department name. If I am, suppose I'm making into decomposition this table. How? Like employee table as one side and department table as second relation or second table. Like employee table consists of which columns? EID column, e-name, age, city, salary. Okay. This whole up to salary, we can call it as employee table. Coming to department table, EID, department ID, department name. Why I am taking again EID? To recognize the person, so and so person, he is in this department. His department name is this one. If we combine also, we'll get this same table. That is what lossless joint decomposition. Okay. So if we decompose the above relation into two relations, what is the decomposition? See here. Employee table consists of EID, e-name, age, city, salary. Okay, this is the first one. And what is the schema we'll be having? EID, e-name, age, city, salary. Next in second table, department ID, EID, department name. If I combine these two tables, we'll get this one. Okay, is it clear? Lossless decomposition, yes or no? So what I have done here, decomposition is the process of breaking down into parts or elements. It replaces a relation with a smaller relations. And coming to the lossless joint decomposition, a decomposition must be a lossless even the information or relations even if we are splitting into the two tables, the data should not get lost. It should give a guarantee that if we are joining the tables, two tables or multiple tables, so the data should not be lost. So this is the example for employee department table. For this, we are making into lossless decomposition, making into two relations. One is employee table and second one is department table. Employee table consists of this schema like EID, e-name, age, city, salary. Coming to department table, department ID, EID, department name. So department schema consists of department ID, next EID, next this one. So the decomposition is a lossless join because two relations contain the common field as EID. Therefore, join is very easy. Okay, join is possible. So here we can apply natural join. Okay. So employee table consists of EID, e-name, age, city, salary. Department consists of department. So here it is not possible to join the two tables or relations because no column is common in between them here according to this one. When it is lossless joint decomposition means we can give a common column name. Okay. Next, dependency preservation. So this is one of the important property, dependency preservation. So dependency preservation is an important constraint in a database. What is meant by constraint? Condition. Dependency is an important constraint on a database. Every dependency must satisfy at least one decomposed table. Okay. Every dependency like x tends to y is there. X is holding y. So here that x tends to y, it should satisfy at least one decomposed table. Okay. Dependency preservation is nothing but every one condition is there. Main condition is every dependency must be satisfied by at least one decomposed table. If A tends to B, A is dependent on B, holds the two set of relation functional dependent, and it becomes more useful for checking the dependency easily in a same relation. So this decomposition property can also be done by maintaining the functional dependency. So in this property, it allows to check the updates without computing the natural join of the database structure. Okay. So here main important thing you need to remember is every dependency must satisfy at least one decomposed table, and if we are having A tends to B, then two sets are functional dependent. Why? B is dependent on A. Okay. So it becomes more useful for checking the dependency in a sets, both sets in a same relation. So this property can only done by maintaining the functional dependency. Next, let us see what is meant by functional dependency. Functional dependency is a relationship that exists when one attribute uniquely determines the another attribute. Like I said, here, according to this, here salary is dependent on rating. Here, salary rating, we can call it as a functional dependent. Salary is dependent on rating, right? So here also, functional dependency is a relationship that exists one attribute uniquely determines another attribute. Here X and Y are functional dependencies, and it is represented as a X tends to Y, which specifies X is functionally dependent. Y is functionally dependent on X. Like salary is dependent on rating, right? So similarly here also X tends to Y is nothing but which specifies Y is functionally dependent on X. Therefore, X can be called as determinant or identification key. Okay, identification key. Suppose example department ID, department name is there. So this can be determined as a department ID tends to department name. Why? Department name is based on department ID. Okay. So here department ID can be called as a identification key or determinant. Is it clear? Yes or no? మా ఒక్కసారి ఇవి అర్థమవుతాయని నార్మలైజేషన్ కాన్సెప్ట్స్ అర్థమవుతాయమ్మా. చెప్పండి, ఏమైనా డౌట్స్ ఉంటే అడగండి. Yes, any doubts up to this? Guys, are you getting my point? Yes or no? ఏమా చెప్పరా, ఎవరు చెప్పరా, అర్థమవుతుంది లేదు? అట్లీస్ట్ చాట్ బాక్స్లో అయినా పెట్టండి. మీరు చెప్తేనే నేను ప్రొసీడ్ అవుతా, లేదంటే మళ్ళీ స్టాప్ చేస్తా ఇక్కడికి. Okay. So till now we have seen functional dependency, dependency preservation, and some lossless decomposition, decomposition definition, and anomalies, right? Next, normalization concept. So normalization is nothing but it is a process, okay? It is a process of organizing the data into database to avoid, I said earlier, no, what is meant by data redundancy, insertion anomaly, update anomaly, deletion anomaly. Normalization is an important concept. Why we are going for normalization? It is a process of organizing the data in a database to avoid data redundancy, insertion anomaly, update anomaly, deletion anomaly. What is meant by redundancy? Multiple copies will be present at different locations. Okay, same copies, so that the wastage of space and time will be there. And coming to insertion anomaly, while inserting the data, without inserting one value, we cannot insert the other value. Okay, next coming to the update anomaly. What is mean by update anomaly? While we are updating some 100 records, in that 90 records are updated. Again, what about 10 records? Even though same matter or same content is there in between 90 records and 10 records, we could not able to update the this issue. So 10 records will be in inconsistent state. Okay, the both the data which is there in 90 records and 10 records are data inconsistent. Coming to deletion anomaly, what we are going to do in deletion? If I am giving any command, delete means based on rating, salary is fixed. Okay, I am going to delete rating 8 means what will happen? Salary column of that particular person also will be deleted. But my intention is to delete only the rating column, right? So here functionally dependent. So avoid all those things: data redundancy, insertion anomaly, update anomaly, deletion anomaly. We go for normalization. Okay. Normalization is also said to be a schema refinement. It is performed to reduce the data redundancy, mainly used for reducing the data redundancy. So normalization is used to avoid data redundancy, insertion anomaly, update anomaly, delete anomaly. So anomaly, I said what is meant by anomaly. Anomaly is nothing but a problem or a issue, an error. Okay. Some undesirable consequences may occur during updating the files, during updating the database. Okay. Normalization works through a series of stages called as normal forms. What is meant by normal forms? We are having different types of normal forms, right? First normal form, second normal form, third normal form, BCNF, fourth normal, fifth normal form. What is meant by normal forms? Normalization works through a series of stages. How many stages are there? 6 stages. That is called as normal form. So let us see what is meant by first normal form. These are interrelated. If ఒక నార్మల్ ఫామ్ అర్థమవుతే ఇంకోట సెకండ్ది థర్డ్ది ఫోర్త్ అలా అన్ని ఇంటర్ రిలేటెడ్ ఉంటాయమ్మా. So let us see first normal form. Before going to this normal forms, let me explain what are the advantages of normalization. Why we need to go for normalization? To minimize the redundancy, to avoid the insertion, deletion, update anomalies. We are going right. Not only that one, we are minimizing the data redundancy. We are maintaining the data consistency, data integrity. Data integrity is nothing but accurate data. Okay. Coming to the data consistency, correctness of data. Okay. The data which is there, that will be correct in all the tables, all the locations, all the multiple tables. Okay. Advantages. Coming to disadvantage, we are also having disadvantage that performance decreases when normalization of the tables, even we are going to the higher normal forms like 4NF, 5NF. First normal form, this allows the multi-valued attribute. Okay. Now let's see first normal form. Mm. So what is meant by first normal form? A relation will be first normal form if it contains an attribute or a column. Okay. If you observe here, example, EMP ID, EMP name, EMP address, EMP mobile is there. A person can have many mobile numbers. Yes or no? Even a normal layman's are also maintaining two SIM cards, two numbers, two contact numbers. Yes or no? So likewise, here what is our main intention in first normal form? First normal form condition is that it should hold only the atomic values or single values. That is the condition. What is the first one? It should be atomic. Each column name should be unique. In 1NF, no duplicate rows should be there. Okay? No duplicate rows. Here, if you observe, EMP ID, suppose a company wants to store some names and contact details of the employee, it creates a table like this. EMP ID, EMP name, EMP address, EMP mobile. Okay. So here, if you observe, EMP mobile contact numbers are having two for EMP ID 1 or 2. What is our condition in first normal form? It should be atomic. That means it should have only a single value like this 101 Harchesel, New Delhi, and employee number. But here, for employee 102, employee name John, EMP address Kanpur, he is having two contacts number. This is not a 1NF. This is an invalid for 1NF. On this time, what we are going to do? We are going to write once again like 102 John Kanpur, one mobile number, and again one more in one more column 102 John Kanpur, next mobile number, so that it will be having the single value. It will holding the only atomic value. And if you observe the column names which are there, that will be unique. In 1NF, no duplicates. So if we are giving only a single values or atomic values, it will not hold any duplicate rows. Okay. So this is an example. See, to make the table complies with 1NF, we should have the data like this. I said no, 102 John Kanpur is having one mobile number and the second mobile number we have to write like this. So this is what 1NF. So what is here also we can say it is a functional dependency, and here identification key is employee ID and determinants are EMP name, EMP address, EMP mobile number. Now tell me, is this table is 1NF? By seeing this table, you say roll number, name, subject. So this is having unique column names. This one condition is satisfied. So what is our main condition? It should hold only the atomic or single value, right? But here 101 econ OSCN, it is there. Now whether tell me this table is 1NF or not. Chat box లో పెట్టండి అమ్మా. ఆన్సర్ చాట్ బాక్స్ లో పెట్టండి వెదర్ ఎస్ ఆర్ నో. Is this table is 1NF? Yes, what happened? ఎవరు లేరా అమ్మా? ఇంతమంది ఉన్నారు, ఎవరు మాట్లాడరేంటి? మౌనిక, తేజస్విని, వైష్ణవి, వాట్ హ్యాపెన్? చాట్ బాక్స్ లో పెట్టండి. నేనేం మాట్లాడమనట్లేదు కదా, చాట్ బాక్స్ లో పెట్టండి. మీకు అర్థమవుతుందా లేదా? ఈజ్ బిలో దిస్ టేబుల్ ఈజ్ 1NF ఆర్ నాట్? సే ఎస్ ఆర్ నో జస్ట్. ఏమ్మా, లేరా ఎవరు? ఏం మాట్లాడరు అమ్మా, లేరా ఎవరు? ఐ సెడ్ ప్లీజ్ బీ ఇంటరాక్టివ్ మా. అర్థం కాకపోతే అడగండి, నేను మళ్ళీ రిపీట్ చేస్తా, కానీ ఇట్లా సైలెంట్గా ఉంటే కుదరదమ్మా. చెప్పండి, ఆన్సర్ చేయండి. ఈజ్ దిస్ టేబుల్ ఈజ్ వన్ ఎన్ ఆఫ్ ఆర్ నాట్? జస్ట్ సే ఎస్ ఆర్ నో, దట్స్ ఇట్, ఎనఫ్ ఫర్ మీ. మీరు మాట్లాడకపోతే నేనేం చేయలేనమ్మా, నేను కంటిన్యూస్గా చెప్పుకుంటూ వెళ్ళిపోవాల్సి వస్తుంది. So according to this first normal form, this table is not a 1NF. Why? Because 101 name and he is having two subjects. To convert into 1NF, we need to write like this. Like 101 econ OS, 101 econ CN, 103 Ccon Java, 102 Bcon C, 102 Bcon C++. So that means what here? 1NF is nothing but, what is the conditions of 1NF? It should hold only an atomic value or single value. Each column name should be unique. In 1NF, no duplicate rows should be there. So that is what 1NF, first normal form. Next, second one, 2NF. So the table is said to be 2NF if the both the following conditions are full. Like table, second normal form అయ్యుండాలంటే first the table must be a one normal form. What is one normal form? First normal form, the value should be atomic. It should hold atomic value. Okay, that is the first condition in second normal form. It should not hold, or it should not have any partial dependencies, means primary key should not have any duplicate values. What is meant by no partial dependencies? The primary key should not have any duplicate values. So second normal form improves the data integrity, nothing but accurate data it is going to maintain by using the 2NF. So see here, it going to prevent update, insert and delete anomalies. By using second normal form, we can avoid update anomaly, insert anomaly, delete anomaly. Okay. See here, example, name is there, roll number is there, branch is there, languages known is there. Okay. So what is our main intention? The table must be in 1NF. If you observe here, the table is in 1NF already. Okay. Now, it should not have, second one, what is the second point? No partial dependency, means primary key should not have duplicate values. So I'm decomposing this table into two tables. One is with primary key, no partial dependencies. Like first we can take name, roll number, branch. Okay. Sai 21 CSE, Shiva 22 AML, Raju 24 DS. Okay. Next, creating partial dependencies. Partial dependency means primary key and only it should not have any duplicate value. If you observe here, any duplicate values are there after creating the partial dependency? No. Okay. So roll number and languages. No partial dependency means primary key should not have any duplicate values. Primary key will not have any duplicate values in this second normal form. Now, is this table is 2NF? Is this table is 2NF means the table should be 1NF and it should not have any partial dependencies. Means the primary key should be unique, have unique values. It should not contain any duplicate values. Next, third normal form. Coming to third normal form, third normal form is said to be a second normal form if they follow the conditions like first the table must be 2NF. Before the table must be 2NF means it should be 1NF also, right? So table must be 2NF, the condition is 1 and there is no transitive functional dependencies. So let us see what is meant by transitive dependencies. 2NF is nothing but 1NF plus no partial dependency in 2NF. Right? Coming to third normal form, 2NF plus no transitive dependency for non-prime attributes, non-primary key attributes. So one primary key is dependent on non-primary key attributes that are called as transitive functional dependencies. One primary key like unique keys is dependent on non-primary key attributes like name, and also branch like that. Okay, one primary key is dependent on non-primary key. Suppose EID is dependent on some department name. Okay, so we can have multiple department names, same names, right? Here key ID will be different. So let us see the example. EID, EMP name, department ID, department name is there. So here in this table, department ID determines EMP name, department ID, and also department ID determines department name. Okay. So therefore, EMP ID determines department name also. Okay. By using EMP ID, we can know the department name of the so and so employee. How? Via department ID. So here we have transitive functional dependency. So this structure does not satisfy the third normal form according to this table. Okay. So remove the attributes which are dependent on non-key attributes from the original relation. So create a new relation with non-free attribute which is determinant in the transitive dependency as a primary key and dependent as a non-key attribute as a dependent one. So suppose see here this table name, roll number, branch, fee is there. So we can how we are going to divide no functional or no transitive dependencies means name, roll number, branches one relation and branch and fee like rating, salary is dependent on rating, like fee is decided by the branch. Based on branch only fee is going to decide, right? Similarly, we call it as no transitive dependency means it should not have like primary key is dependent on non-primary key attributes. Okay, what is meant by primary key? It should have unique values and it should not have any empty values. Okay, all no duplicates are allowed. All those things called as a primary key. Non-primary key, it may allow duplicate values. Okay. So 3NF is nothing but 2NF plus no transitive dependency for non-prime attributes. Name, roll number, branch, fee. Okay, we can making into two relations like name, roll number, branch is one and branch fee is other. Okay, where fee is dependent on branch called as transitive dependency. So here after making into 3NF, we will be getting two relations. These two tables name, roll number, branch, fee. Okay, is it clear? Up to this clear? Yes or no? చెప్పండమ్మా. Next. Now you have to say whether this table is 3NF or no. 3NF means it should satisfy 2NF plus it should not have any transitive dependency, right? Next, boys code normal form. So this is an advanced version of third normal form called as 3.5. It is also said to be a 3.5 normal form. BCNF is the advanced version of third normal form. So what are the rules will be there in BCNF means a table is said to be BCNF when it is a 3NF, and also for any dependency A should be super key. For any dependency keys there means A is, tends to B or X tends to Y, A should be or X should be a super key. Okay. So let us see the example. So this is a table. Okay, employee nationality, department type, department number. So here we can take X tends to Y. Like we can take this EMP ID, EMP nationality we can take. See, EMP ID tends to EMP nationality. So again, EMP ID can contain department type and department number EMP. So boys code normal form, it should be it's said to be a 3.5 normal form. It should satisfy the third normal form, and also it should have some dependency like A tends to B means A should be a super key. Here X and Y or A, you can take employee ID, employee nationality. So these two are called as X tends to Y, suppose. So here X should be a super key. EMP ID should be a super key. Definitely it should be a super key. Why? Roll number here. By roll number only we are going to derive the remaining things, right? Only a one value will be like only a unique value will be there in super key 101. Okay. Next example. See, super key 1 2 3 4. Example. This table is an other table which is not a BNF. Here roll number nor branch ID are not alone or keys. So to make the table compile with BCNF, we can break into three tables. One is roll number, student name, branch ID, and branch. So here we can make it as roll number as a super key 1 2 3 4. 1 2 3 4 unique values are there. Student name. Okay. Next coming to this one, branch ID and branch name. With the help of super keys, we can make it into a or decompose into it some tables. Okay. It should be a boys code normal form. It should be a 3NF plus along with this one X tends to Y. If any functional dependency is there means X or A or some whatever it may be, that should be the super key. Okay. Next, fourth normal form. Fourth normal form. So when fourth normal form is going to happen means a relation will be 4NF if it is in BCNF, and it should not have any multi-valued dependency. So a relation will be 4NF if it is BCNF and it is not having any multi-valued dependencies. Suppose three columns are there: student ID, course, hobby. Okay, what is student ID here? 21, 21, 34, 74, 59. These are the IDs. And course are computer, mathematics, chemistry, biology, physics. And hobbies are dancing, singing, dancing, cricket, hockey. Okay. So this table is BCNF. This table or this relation must be BCNF. First, before going to convert into fourth normal form, the relation should be in a BCNF and table should not have any multi-valued dependencies. A table is said to be multi-valued dependency if that following conditions are true. For dependency A tends to be if for a single value A, multiple value of B exists. Okay, then the table may have multi-valued dependency. So here the given student table is 3NF. Okay, here course and hobby are two columns like student ID and hobby, and there is no relation between course and hobby. Why? To identifying this table, it is difficult. Okay, if we decompose into course and hobby, is it meaning of a table? Will it give will it is a valid table? No, no. So here there is no relationship between course and hobby. Here we can make it as a student ID course, student ID and hobby. Okay, so that is what fourth normal form. It should not have any multi-value dependencies. Okay, so student ID course, student hobby. So this is an 4NF. 4NF means it should be a BCNF and it should not have any multi-valued dependency. Okay. Next, we can say this also bike model, manufacture, year, color. So whether this table is a 4NF or not. So now before converting into 4NF, the table should be BCNF and it should not have any multi-value dependency, right? So here, according to this one, we can make into two tables. What is that? First bike model and manufacture year, and second table or second relation as a bike model and color. Okay, we can make into two relations. That is what fourth normal form. Next, coming to the fifth normal form, 5NF. 5NF is totally said to be 5NF when it is going to satisfy the 4NF. What is 4NF? It should not have any multi-value dependency. Okay, so it does not contain any joint dependency here. What is our condition? It should be 4NF and it doesn't contain any joint dependency. So 5NF is satisfied when all the table present in the DBMS broken down into many more tables to ensure there is no redundancy. If we compose the table into further eliminate the redundancy anomalies, if we rejoin the decomposed tables, that means the candidate keys, we should not lose the original data or any new record. Okay. In simple words, joining two or more decomposed table should not lose the records or nor it should not create any new records. So see here example, subject, lecture, class. Subject is Max, lecturer is Alex, Sem 1. Like that, subject column is there, lecture column is there, class column is there. So let us see example. So we can represent by existing table into three tables. What are that? One is subject lecture and second one is lecture class and third one is subject class. Okay, so here subject area and their classes are in better way. We can divide into three tables, that is subject lecturer, lecturer class, subject class. So select as T3 dot class, T3 dot subject, T1 dot lecture, so that we'll get the tuple of first one. Okay, from which table? Table 3, table 2, table 1, where T3 dot class equal to semester 1, T3 subject equal to physics, okay, and T3 class equal to T2 dot class and T1 lecturer equal to T2 lecturer. Now we can make it this also agent company product, like agent company, company product, agent product. So these are the 5 normal forms, 6 normal forms. So these are the stages. First stage will be unnormalization Non-normalized relation. Next, first normal form, second normal form, third normal form, BCNF, fourth normal form, and fifth normal form. So, what are the actions will be happened in different stages? Means, see here. In first stage, unnormalized relation is nothing but removing the repeating group will be happened. After performing the first normal form, here atomic values will be holding, right? Single value or atomic values will be hold. So here, while converting first normal form into second normal form, removing partial dependencies will be happen. After that, we are converting into second to third normal form. Here we need to remove as well as it should be a second normal form, and we should remove transitive group. Next, third normal form is nothing but we should remove functional dependencies. Next, BCNF. Here in BCNF, it should remove multi-valued dependencies. Coming to the fourth normal form, it should remove remaining anomalies. This is the fifth normal form. So these are the stages and actions. So with this normalization concept completed, schema refinement completed. Let me give a summary of this one. Then I'll move to the next transactions concept. So here we have seen the combining, how to combine the schemas. Two different tables are there, instructor table, department table. By combining instructor department table, here lossless join decomposition will be happen. So here repetition of data will be possible. If we are combining schema without any repetition, means here considering as two relations and making into one relations, here we need not to take as a two columns this section ID. Next, decomposition is nothing but it is a process of breaking down into parts or elements. Next, the properties of decomposition are lossless decomposition, dependency preservation, lack of data redundancy. Next, coming to lossless decomposition, decomposition must be lossless. It means that information should not get lost even if we are joining the two tables. Okay. Yes, this is the employee table, this is the department table. If we are combining these two tables means it should not lost any information. Okay. Next, dependency preservation. It is the most important condition of a database that every dependency must be satisfied at least one decomposed table. That means A tends to B. So that two sets of functional dependency, and it becomes more useful for checking the dependency easily. Next, coming to functional dependency, here a relationship exists when one attribute uniquely identifies the another attribute. If R is relation with attribute X and Y, functionally X tends to Y. So here X called as a determinant or identification key. Next, lack of data redundancy. So lack of data redundancy is also known as repetition of information. The proper decomposition should not suffer from any data redundancy. Okay. Next, coming to normalization, why we are going for normalization or schema refinement to avoid all those things like data redundancy, insertion anomaly, update anomaly, deletion anomalies. Okay. Next, we are having some normal forms, six normal forms. What is mean by normal forms means normalization works through a series of stages called as normal forms. First normal forms, it should satisfy the conditions like it should be atomic, each column name should be unique, no duplicate values. Okay. Next, second normal form, it should satisfy the first 1NF and it should not have any partial dependencies, means primary key should not have any duplicate values. By second normal form, it may improve the data integrity and it prevents the update, insert and delete anomalies. Next, third normal form, it should be the table must be a 2NF and there is no transitive, there should not be any transitive functional dependencies. So one primary key is dependent on non-primary key attribute. Next, BCNF, this is an advanced version of 3. Third normal form, this is also called as 3.5. Table must be 3NF. What are the conditions? Table must be 3NF and every functional dependency X tends to Y. X should be a super key of a table. Next, fourth normal form. Here it is going to maintain independent many to one relationship and it should be a DCNF. The table should not have any multi-valued dependencies. Next, fifth normal form. It should be in 4NF and it should not contain any joint dependencies. So these are the stages and actions of normalization. So up to this clear? Yes or no? Next, I'll move to transaction concept. Next, transaction management. So these are the outlines we are going to learn in management, transaction concept, transaction states, concurrent execution, serializability, recoverability, implementation of isolation, transaction, definition in SQL, testing for serializability. Transaction concept. We already know what is meant by transaction. Okay. A transaction is a unit of program whose may change the content of database. Okay. What is meant by transaction? It is a one unit of program who may change the content. Suppose I'm making the changes in the database of CSEDS. Okay. So I'm the person who is going to do the transaction. Okay. Transaction is nothing but a unit of program whose may changes the content of database. Example, banking database. So while updating the some content, it is going to change the database, right? Contents will be changed while updating, while doing some any transactions. Suppose by T1 is there. T1 is used for selecting the transaction. By T2, some like number of T1, T2, T3 transactions is happening in a banking database. T1 part is first selecting the transaction. Next, after selecting, what we are going to do? Inserting. Like we can do the operations like deposit money, we can receive the money, we can send the money, right? Inserting the money. Next, third one, we can update, transfer the money by making into login some credentials. Okay, using some authentication, we can update, we can transfer the money. So these many transactions we are doing. Transaction is nothing but a unit of program whose may changes the content of database. Okay. So example, banking database. Banking database is nothing but how contents are changed in a database. So here three are there. One is T1 selecting transaction 1, that is. Next, T2 is inserting the deposit, like operations we are going to do is deposit money. Next, T3 transaction 3 is transferring the money, update. So a database before transaction and after transaction should be in consistent state, then only we can call it as transaction gets successful. If the transaction before transaction in the database is same and after doing the transaction, whether it is not going to update or whether we are getting any error, any failure occurred, means what will happen? The data may leads to inconsistent state. Okay. So here a database before transaction and a database after transaction should be consistent state. Okay. So it consists of some of the operations like executed between begin and end. While writing the program, we need to have the syntax like first we need to write begin and after doing the transaction, completing the transaction, we should write end. It should be consistent is nothing but correctness of the data. Okay. So suppose example for this transaction. One minute. 1. Now see here, in account A, we are having 300 rupees. In account B, we are having 400 rupees. Okay. Both two accounts are there. In account A, account name as A, we are having 300. In account B, we are having 400. Okay. So now, if I want to transfer 100 rupees from account A to account B, what will happen? Suppose I need to write this type of program. Read A. How to read A? In A, we are having 300. After read A command I'm giving, what will happen? It is going to read the 300. Next, now what is my intention? I want to transfer 100 rupees. So A equal to A minus 100. Why? To I want to transfer 100 rupees to B account. Next, after this second step, what will happen? 100 rupees is deducted. Next, coming to third one. Now A account is added 100 rupees. Sorry, decreased to 200 rupees. Why? After giving the command A equal to A minus 100, it is going to deduct 100 from which one? Account A. Now A account is having only 200 rupees. Now second step, read B. Read B means nothing but reading the B account. How much is there? 400. Now what happened? B equal to B plus 100 here, not 50, 100. So here the amount from which A is transferred to amount account B. Okay, amount is transferred from where to where? Account A to account B. Now after giving the right B, what will happen? Now B value become as a 500 because already account B contains 400 rupees. Now B value how much? 400 plus 100 equal to 500. Okay. So before transaction A plus B equal to 300 plus 400 is 700. After transaction also A plus B equal to 200. After transferring the amount from A to B, what will happen to A? It will be 200. Now B will become 500. Total 700. So before after transaction, the data should be in consistent state without any problem. To make the database in consistent state, we'll use some properties on transaction, that is acid properties. Okay, this is the transaction concept. Transaction concept is nothing but a transaction is a unit of program whose execution may changes the content of database. Okay. Example, in account A 300 is there, in account B 400 is there. Now if I want to transfer 100 rupees from account A to account B, what will happen? First I need to read A. So reading the operation A, here it is going to read 300 from the A account. Now I want to transfer 100 rupees from account A to account B. What will happen? I need to give a command A equal to minus 100. So that 100 rupees is deducted. Next, coming to the third step, write A. Now A account is having 200. Okay. Next, read B. Read B. What will happen in read B? Amount is transferred from account A to B now. B will become a value of 500. So Therefore, the database is in consistent state without any problem. Why? Before transaction, how much value is there? Next, after doing the transaction also, that much amount or that much account balance is there. Okay. Next, to make the database in consistent state, we will be having the following the some of the properties like acid properties. So to ensure integrity of data accuracy, completeness, correctness, we go for acid properties. Acid is nothing but atomicity, consistency, isolation, durability. Atomicity, consistency, isolation, durability. Acid properties, if transactions satisfy the acid properties, that the data will be in consistent state. A successful transaction changes a database from one consistent state to another consistent in order by using the acid properties. Okay. So in order to maintain consistency in database before or after transaction, it has to perform or certain properties should be followed. Acid properties. In order to ensure the integrity of a data, accuracy, completeness, we use acid properties. Atomicity is nothing but it states the transaction, it should be atomic. Like we have seen in 1NF, no? So here the date states whatever the states while doing the transactions, it should be atomic. It should have a single value. Either all the operations uh, of a transactions are reflected properly into the database or not. What is this statements mean? If we are doing any transaction, all the transaction should be completely done or it should not be done. Okay. So if a part of transaction is failed means entire transaction will be failed. So if the states of transaction must be atomic, atomic means either all its transactions are executed or none of the operations. So we call it as all or nothing rule. We call it as all or nothing rule. So here atomicity has two operations. One is abort and second one is commit. One is abort and second one is commit. So here abort is nothing but changes made to database are not visible. Abort is nothing but changes are made to database are not visible. Commit is nothing but changes made to the database are visible. Abort is nothing but after doing the transaction, even if any failure is occurred means it is not visible to the everyone. Abort. Commit means it is visible. Commit means successfully done. Okay. So if one part of transaction is failed means entire transaction will be failed. So if we are doing some transaction, sudden any occur or any problem has been raised means it will lost and leads to inconsistent state. So main acid properties intention is to avoid inconsistence, right? So let us see the example of atomicity. If two transactions are there, T1 and T2, two transactions. So transferring 100 rupees from account A to account B. Okay. So A equal to 500 and T1. Read of A equal to minus 100, write A. So in T1 transaction, what is happening here? A equal to 500 is there. In account B, how much is that? 200. So this is T1 transaction, right? I need to read A. So how much it is there? 500. It is going to read. Now I want to detect 100 rupees. Okay. Now I want to transfer 100 rupees from A to B. What will happen? A equal to A minus 100 means it is going to deduct from A account. Right? A means what will happen now? What is the result of this one? A is already transferred some 100 rupees to the B. Now what is the value? 400. Next, coming to the B account, what will happen? We should read first B. Okay. After reading B, B equal to B plus 100 will happen. Next, write B means the value of B is 300. Now, before transaction of A and B is 700. After transaction of A and B is 700. Therefore, it is in consistent state. Okay. Therefore, we can say it as a consistent state. The data will be in consistent state, correct state or correctness, data accuracy it is going to maintain. If transferring A to B before transaction fails after T1, what will happen? The data or the result will be in inconsistent state. Because from account A, it will be deducted, but in B, it was not added. Okay. Next. So properties, second one is consistency. So consistency is nothing but correctness. Correctness. A transaction when starting to execute must consider as a consistent correctness. During the transaction of execution, the database may be temporarily inconsistent. First, during the transaction. When transaction completely successfully done, the database must be consistent. Okay. So example, sum of A and B is there. Okay. Before transaction, A, B is 500 plus 200, 700. After transaction, it may become 400 plus 300. Same. Database is in consistent state. Next, isolation. Isolation is nothing but actions performed by the transactions will be isolated or hidden from the outside. So actions performed by transactions will be isolated or hidden from the outside transaction until it is going to terminate. So isolation can be ensured trivially by running transactions serially, nothing but sequentially. That is one after the other. Okay, the transactions will be in isolation state. Suppose T1 and T2 are there too. Okay, read A means it is going to read the content of A. Next, I want to transfer 50 amount to the T2. What will happen? 50 going to detect from the A. So right, after writing the A, what will happen? It will be 200 is there means minus 50. 150 will be there. Next, after reading writing we have to print AB, right? Next, what will happen? If B plus 100 is there, it will be going to 100, not 100, plus 50 is there means it going to read the B value. So data used during execution transaction cannot be used by until first one is completed. Okay. Okay, until first one is not completed, the remaining second transaction will not be done. Next, durability. All updates done by a transaction must be become a permanent commit statement. Okay, so all updates done by a transaction must be become a permanent commit statement until we changes a value in database will not be removed. Okay, first one is transaction or nothing, acid properties. Next, C is consistency, only valid data is saved. I is nothing but transaction does not affect each other. D is durability, written data will not be lost. Hmm. So see the simple transaction model. A transaction accessing two operations, that is read and write. Okay, read is nothing but which transfers the data item from the X from the database to local buffer belonging to a transaction that executed the read operation. Next, coming to the write X, which transfers the data item from X from the local buffer, and the transaction that is executed right back to the database. If you observe here, what is T1? Read A equal to A minus 50. Now it should write, right? Write A. 1 minute, ma. So now write B equal to B plus 50. Now it is going to write the B. So from A, 50 will be deducted, and from for A, B, 50 will be added. So this is a transaction model. Two operations, read and write. So in next class, I'll explain storage structure. Till now, what I explained, I'll give a summary on acid properties. Why? Because this is very important concept. Mm. See here, concept. Transaction concept are nothing but a transaction. It is a unit of a program whose may changes the content of database. Okay. A transaction, it is a unit of program whose after doing the transactions, the content may changes or the updations may changes in a database, right? That is called as a transaction. If suppose phone pay or gpay or any upi pay, now we are doing right now, okay, right? So here, what will happen if I'm doing any transaction, I'm transferring from one mobile to the other mobile. What will happen here? It shows the transactions and it is going to change the content of his database. Already history will be there, no? If I am doing any transaction successfully done means in history, this will become as a recent one. Okay. For example, banking database is there. So banking database here, how content changes will be there in, we are going to see in database. Okay. So some transactions like T1, T2, T3 is there. By T1 is nothing but by selecting the transaction. First, we need to select the transaction, right? If we are having some account, I want to transfer from account A to my friend's is account B. What I will do first, I will select the transaction, like which type of transaction I am doing, like IMPS, NEFT or something. Okay, like that we need to choose, we need to select the transaction. Next, second transaction, what will happen means, what is the operation means, inserting, depositing the money. Nothing but value we need to give some authorizations. Not authorization in this step, only we need to insert the how much money we want to deposit or transfer. That is the T2. Next, coming to the third one, after depositing, it will now T3 will become update transferring money. So a database before transaction, a database after transaction. Main transaction concept is before doing the transaction, after doing the transaction, the data must be in consistent state. So it consists of all operations executed between begin and end transactions. Next example. So in account A 300 is there, in account B 400 is there. Now if I want to transfer 100 rupees from account A to account B, what will happen? First I need to read A, right? How much is there in A? 300. So reading 300. Next, I want to transfer 100 rupees. What I need to give? I need to give A equal to A minus 100. So that here what will happen? 100 rupees will be deducted from the A account. Next, what is the command I need to give? Write A. After deducting, write A I need to give. Why? Now the account will be having the 200 rupees. Why? because 100 rupees is detected from account A. Next, coming to the fourth step, what will happen here? Now, account B, which is there, that is going to read 400. Next, after reading into 400, what will happen? The amount which is transferred 100, now that B become transferred account from A to B. So now, write B is nothing but how much amount. The remaining value it is going to display. So this is what transaction concept. Okay. So main intention, main goal or main important constant is before transaction A plus B is how much? 300 plus 400, 700. After transaction how much? A plus B equal to 200 plus 500, 700. So therefore database should be in consistent state without any problem. To make the database is in consistent state, we'll use some properties on transactions that is called as acid properties. Acid properties are nothing but atomicity, consistency, isolation, durability. So what is mean by atomicity? Atomicity is nothing but it states the transaction must be atomic. Means here it should update like all operations are done in a transaction or it should not done. Okay, it should show the complete transactions or it should not show the complete transactions like that. If one part of transaction, one side or one part of a transaction is failed means entire transaction is going to fail. Okay, so atomicity has two operations. One is abort and second one is commit. Abort is nothing but after doing the transactions, any failure is occurred means it automatically it is going to abort. Okay, next. Commit is nothing but changes made to database are visible. Changes made to database are visible. In abort, it is not visible. So in atomicity, if T1, T2 are two transactions, transfer 100 rupees from account A to account B. So A equal to 500, T1 and read of A. A equal to A minus 100. It will become now 400 value of A. Next coming to B. B is already 200. After transferring from account A to B, what will happen? B will be increased to by 100. Now the value is B is 100. So before transaction A and B is 100, after transaction A and B is also 100. Therefore, it is in inconsistent state. Sorry, consistent state. If transferring A to B before transaction system going to fail, what will happen? Now T will be in one state and T2 will be in other state. So this may leads to inconsistent state. Next, consistency. Consistency is nothing but correctness. A transaction when starting to execute, it must consider as a consistent. So during the transaction execution, the data will be in temporary inconsistent state. So when the transaction completes successfully, the database must be in inconsistent. Base must be in consistent state. So here, after sum of A and B is before transaction is same. After transaction, sum of A and B is also same. Durability. Coming to durability, here the database which is there after doing the transactions will not be changed. Once the user has been notified the transactions has to complete, that is the transfer of 50 has been take place. The updates to the database by transaction must be consistent. If even there is a software or hardware failures, the data will not be lost. If you observe in our phone pay transactions histories, it is going to main. We cannot delete that histories, right? So we call it as a that we call it as a durable. Isolation. Isolation is nothing but it will run one after other, running the transactions one after other. If between the steps 3 and 6 here, 3 and 6 are nothing but write A, write B, then the other transaction T2 is allowed to access the partially updated database. It will see an inconsistent database, sum A plus B will be less than it should be. Okay, T1 is read A equal to A minus 50, write A. Read B equal to B plus 50, write B. So these are the acid properties. So simple transaction model. So two operations, read operation and write operation. Read operation is used to transfer the data item from database to the local buffer. Okay. And that is going to read the operation. Next, write operation which transfer the data item from the local to, and again it is going to write back the database. So with this I'll close now. Storage structure tomorrow I'll explain. So up to this clear or having any doubts? So today I have explained about transaction, normalizations and data anomalies, schema refinement. Yes, మా అర్థమైందా? Yes or no? చెప్పండి అమ్మా. ఉన్నారు కదా చెప్పండి. So tomorrow I'll explain remaining things. Good night. I'm leaving now.